Hey guys, welcome back. This is Mr. Drew. We're here with another science lesson. Today we're going to talk about changing states of matter. But let's think about this question first. What's the most commonly found state of matter? In the whole universe, is there more solid, liquids, gases, or plasma? What's your vote?
I don't know about you, but if I was on a ship and I saw a glowing sphere of light suddenly floating around the top of the mast, I would be, I think this is the proper term for it, freaked out. But for centuries, sailors saw that all the time, and they thought the mysterious blue glow was a good omen because they associated it with the end of a storm. They called it St. Elmo's fire after St. Erasmus, the patron saint of sailors. But we now know that it's a natural phenomenon. When the pointed end of a ship's mast interacts with the heavily charged air, like during a storm, it can create a ball of plasma. Plasma is the fourth state of matter after solid, liquid, and gas. And even though it makes up 99% of the visible universe, we didn't know plasma was a thing.
Well, surprise, surprise, plasma is the most commonly found state of matter. Why is that? Well, it turns out all of the stars, which are suns, are actually glowing balls of plasma. And stars have more mass than anything else put together. So plasma ends up being the most common and almost commonly forgotten state of matter. Today we're going to continue on with our states of matter and how they change, but let's remember the homework and things that are coming up. You guys have a Properties of Matter quiz due the 11th. There's a folder in Schoology that will give you some chances to review, see if you can beat Bob in the Kahoot, and then take the quiz. You have up to 3 chances to get as high of a score as you possibly can. Superhero Projects due the 11th/25. That's the 25th of November. Please make sure that you go ahead and if you're doing this remotely, you're going to continue with the same document in Schoology. Follow down to the end, put your revised paragraph in paragraph form, and you can cut and paste an image or a drawing that you did. Don't forget the labels. A lot of people forget the labels, or their drawing doesn't show the properties. They just point to a glove and say words, but they don't show the flammability or whatever the properties. So watch out for that. And a new assignment called Liquid Mountaineering that I think you'll have a lot of fun with. Also due 11/25. Again, there's that day again. And it is in your Schoology folder called Liquid Mountaineering. Remember, guys, you can do these things before the due dates, but we just want to keep consistent with having a Wednesday due date for all of these materials. All right, for today, we're going to be talking about changes of states. So you're going to need your packet, and go ahead and take out your notes about the changes of state. Changes of state. Physical changes when matter changes form because of a change of temperature and energy. Go ahead and copy the blue words, and if you need to pause, feel free to pause and fill in your notes. Melting, I'm sure you've heard of before. Well, when the temperature increases in a solid, it actually moves the particles or molecules faster and breaking them apart from their solid crystal structure into something that can move or flow. The molecules are speeding up. As the temperature increases, the molecules move faster. A good example is regular ice. Ice always melts at 0 degrees Celsius, which is 32 degrees Fahrenheit. Vaporization. As you continue to heat or add energy to a material, the liquids will turn into gas. We call this the boiling point. Boiling points occur at a specific temperature for specific materials. Evaporation can also occur. This is when a liquid turns to a gas at the surface without boiling. In both cases, the molecules are speeding up and spreading out as the energy increases. If we heat water up to 100 degrees Celsius, the entire container of water will start to boil. Those bubbles you see are the liquid molecules turning to gas. They are not changing chemically. They're just physically going faster, so fast that they actually spread out enough to form a bubble of gas which rises and goes into the air. Water can exist as a vapor, which is invisible. Evaporation, similarly, is when a liquid turns to a gas. However, this can occur at low temperatures. Even at room temperature, a puddle of water will eventually evaporate into the air. The molecules on the surface, by random chance, could pop off into the air and become a vapor molecule of water. Sublimation is an interesting phase change where solids turn directly into gases. When the molecules speed up enough and spread out enough, the molecule can actually turn to a gas. A great example of this is dry ice. Dry ice is solid carbon dioxide. As the dry ice experiences warmer conditions, the molecules vibrate and quickly turn exactly into gas. They do not go into a liquid form. This is much more rare with regular ice. However, it can happen in certain conditions. Now we're going to take in lower temperatures and slow the molecules down. So starting at a gas, we can think of condensation as gas molecules turning into liquids. When the molecules slow down, they get closer together. There's some forces that draw them together. However, they're able to flow. Temperature energy is decreasing, and water vapor in the air will condense into fog or clouds.
By the science guy.
Hey, I'm in here.
Let's take a quick look at condensation. As Bill comes out of the giant freezer, notice what happens to the helmet.
See, the surface of my bubble helmet of science turns cloudy. That's because water vapor, which was floating around in the air, sticks to the cold surface in little liquid water droplets. Now, this process, this effect, this thing that happens is called condensation. It's the same thing that happens to people who wear glasses when they come in after being outside on a cold day.
Freezing. Let's take a liquid and turn it to a solid. Freezing is often called solidification. Liquids turning into solids because the molecules slow down enough to get close together as the energy or temperature decreases. Crystals often form, which are patterns of molecules that form in solids. If you've ever seen a snowflake, you know what I'm talking about. Liquid water will turn to ice at 0 degrees Celsius, also known as 32 degrees Fahrenheit. All right, let's do a quick review of the things we know. Which of these pictures represents melting? Solid turning directly to a liquid because the molecules are spreading out, speeding up, and becoming able to flow. Boiling is evidence here. Water will boil at 100 degrees Celsius, which means it turns directly into a gas. Condensation. Clouds form condensation because water vapor in the air, which is invisible, condenses on tiny pieces of dust up in the sky where it is much cooler. And finally, sublimation. Remember, turning from a solid directly into a gas. All right, folks, we're in our packet now, and we're going to go ahead and fill in the states of matter organized using small circles. Draw the molecular arrangements of solids, liquids, and gases in the box below. Using colors such as red to indicate an increase and blue to indicate a decrease in heat energy. And the words in the word bank below to help fill in the changes of state. Condensation, melting, vaporization, freezing, and sublimation all can go on the arrows. As a quick example, what you're going to do is draw circles to represent the molecules of a solid. Solids being tightly packed will have lots of molecules tightly packed in our solid. Continue drawing circles until you feel you've got a good representation of a solid. For a solid to turn to a liquid, we're going to need a change of state to occur. That change of state is called melting. And that change of state involves an increase in temperature and energy. The molecules in a liquid are the same molecules. However, they'll be slightly farther apart and able to flow. So I'll put the same 5 molecules in my liquid in a situation where they're able to flow. Continue on doing the same for gas and using your word bank to fill in the arrows. Don't forget to continue working on your final draft for your superhero project. And in your packet, you've done the organizer. There's also something called the Amazing Change of State Experience. And hopefully all of those things will help you as far as understanding the differences between solid, liquid, gas, and how those changes occur. Well, thanks so much for joining us on another science class, and thanks for trying science. See you next time.